So I am Tommy. I am a senior product manager at Polymer Labs. We are focused on building scalable on-chain networking via IBC for Ethereum rollups. And I'll talk a little bit more of really what that means, but also just my experience. So previously, I was a technology advisory consultant at EY. I was also a VP in the finance division at Morgan Stanley, working in third-party vendor tools. And I worked at Nautilus Labs, where we optimize shipping routes, driving decarbonization and fuel savings. I've been at Polymer for just around 8 months now. And a lot of what we're doing ultimately is bringing IBC into Ethereum, and there's a lot of power that can come with that. I think the ultimate goal is a new era where interoperability becomes an implicit feature. And what does that really mean? The end goal of interoperability is to stop talking about interoperability, just simply making it a way of business. The teams that are able to achieve that, especially in the Ethereum landscape, are going to be the most successful. And it really requires moving a mindset away from a chain-specific mindset, which Ethereum is very chain-focused right now, and moving more towards an application-focused mindset. And what does that mean? Some of you have probably heard this type of vision before, but I'm going to walk through actually how Polymer can get there and how we can make it a reality. So I'm going to use an application, Synthetics, as an example. Synthetics provides liquidity for EVM chains. And right now, in the world of Ethereum layer 2s, in order for Synthetics to be where it is today, which is on Ethereum, Optimism, and Base, it needed to do independent deployments and execution engines, which is quite a lot of work. First on Ethereum, then it went to Optimism, then it went to Base. And when you are doing that, you're not able to have liquidity sent at the L2 level. Everything has to go from L1 to L2, and essentially you have the concept of fungible, non-fungible tokens. Now, the other bottleneck is the native bridge. Every application that is built on layer 2 right now relies on the native bridge. And when fraud proofs become a realization, Optimism will be releasing that at some point on mainnet soon, there are certain applications that have to wait 7 days to actually see value and settlement. And then lastly, multiple execution engines means all these applications need to manage multiple state. They are essentially different backends that are all massed together from marketing and branding on the front end. Now, future state, where we really want to live when thinking about application-first mindset, is that an application just has to deploy an execution engine once and has a state store on Ethereum managing the state and has the ability to extend extensions into different layer 2s without needing to have full execution engines. The other thing that an application would want is to be able to dictate their own standards on the native bridge and not solely depend on a 7-day fraud window. Have some sort of say in what risk tolerance applications are willing to take. And ultimately, with one execution engine comes the idea that a chain, that an application can pick the chain that is most optimal for its use case. So there are quite a few problems in order to get to this realization. First off, we have off-chain validation. Right now in the Ethereum landscape, most, if not all, interop providers manage off-chain. And I'll talk about that a little bit more as well. You have lack of messaging standards, which is quite prevalent. The landscape is growing, not only in size, but also in depth. And then you also have dApp dependencies, just like the native bridge and the fraud window. So where do we want to go? We want to really make sure that the validation is moved on-chain, that we are implementing standards, that there is this ability to be adaptable with those standards and the on-chain execution and validation, and that we are thinking, how can an application get the best dev experience and user experience? So first, let's go into off-chain validation moving on-chain. So let's define on-chain first. and I'll do so in the context of what Polymer is working on. So Polymer, right now, we are leveraging Ethereum as the source of truth. What does that mean? How do we do that? So Polymer is an optimistic L2 rollup, which is quite different than most of the off-chain third-party vendor interop services. So what that means is we read and write to Ethereum as well. So when you are trying to send a message, you are not just sending a message from chain A to chain B and going in between a third party. We are essentially reading from Ethereum when message A wants to send something to chain B, and then we are forwarding that to chain B. And that is a concept that we define as extending the native bridge, which is the most secure standard within Ethereum. With that, obviously, comes less trust assumptions because we are trusting the source that rollups are trusting to write to Ethereum, and ultimately it reduces malicious intervention. So now I just want to get a little bit into off-chain versus on-chain. When we are talking about off-chain and chain A is trying to send a message to chain B, if it needs to go through a interop solution today, it needs to circumvent Ethereum, and then that third party is a risky assumption in itself. That third party is not reading from Ethereum. So by nature, it's an additional trust assumption. No matter how trustful a rollup is of Ethereum, there is risk added. And with that, obviously, comes not being backed by Ethereum. You're also looking at the difference between application state and settlement state. So applications, when they are working with a third-party vendor today, the third-party vendor is relying on application state, which, yes, it is fast, but it is also risky. And what we are trying to rely on is settlement state, which is one step further to finality. Now, on-chain, when you move to on-chain, you are essentially, there are less trust assumptions. We are trusting the same standard. You have flexibility in the way in which these applications want to write to Ethereum. And I'll talk about that a little bit more as well. I could probably spend an entire presentation on that, so I'm going to try to keep it succinct. And then also there are different verification methods required to keep up with Ethereum's speed of scale. And there's also this concept of a private network that applications can have, going back to my picture of being able to send messages L2 to L2 privately. So now that we've spoken about on-chain and really the differences between on-chain and off-chain, let's get into implementing standards. And a lot of the reason that we're all here today is to talk about IBC. And Polymer uses IBC as the way in which we are sending messages. And that is the standard that we believe. It's the closest thing to TCP/IP that exists. And it is a credibly neutral standard that, just to give a lowdown on it, in case anyone here is not familiar with, you have clients, connections, and channels. And you can think of them similarly to clients are the traffic control in cities. Connections are essentially the highways connecting these cities. And then channels are the actual lane that you pick within that highway, making sure that you are able to have different sort of say in how these messages are transacted. And connections and channels are created via the handshake process, which I have detailed up here. It's ultimately a way to make sure that the two chains are agreeing upon a language that they want to communicate that is private and secure. And lastly, we have packet flow, which is extremely important because every third-party interop tool within Ethereum does send a message, but does not make sure that that message is received correctly. And a huge asset to IBC is that we have acknowledgements. So now that we've gone through on-chain definition, we've gone through standards via IBC, let's also get into adaptability. When talking about adaptability, it's important, again, to level set that the Ethereum landscape is not just growing laterally. It is also growing in depth. So base leads to shards with L3s. It's probably going to catch on. There probably will be more L3s. Who knows where that scales into? But ultimately, all of these different layers create interoperability challenges. And right now, you have a lot of solutions that are solving isolated problems for isolated solutions. And it's similar to a hamster running on a wheel. You probably will never play catch up, but you can probably prioritize the most profitable chains and get away for a while. At some point, something else is going to be far superior. So let's just do a quick level set of a very similar problem that happened in Web 2 during the 90s, during the dot-com boom, where you needed these different verification standards during the protocol wars, where TCP/IP won. You also have multi-layer chains, which in the late 2000s, there's a very similar landscape with microservices. So first, let's get into verification standards. With verification standards, some of you may not even really realize the different websites that you may be going on to, but there are different standards as far as different HTTP, HTTPS, SSH. These all just have varying different levels of security and speed. And within the Ethereum ecosystem, we also believe that that is a path to scale. There is no one-size-fits-all solution. It's also quite well known that some solutions are easier than others. An institution may be more reliant on a self-relay because a proofing system may not be feasible for them. We also have Lagrange-like clients, which Lagrange is able to scale to certain chains at a faster rate than we can. So we can really leverage that, work with them, and really have the application decide, given their options, what is best for their use case, and really trying to meet the market where it is today versus trying to force standards that maybe are not highly needed at this moment. And going into the multi-layered solution, I dropped a little bit about microservices a couple slides ago. In the late 2000s, Amazon is one example. Amazon had a very monolithic application built, which essentially meant every single edition, a lot of break one thing, fix another, fix one thing, break another. It was quite common. So what they started to do is they started to break it out into a payment method being a different submodule and a microservice. Checkout method, web servers. They really started breaking this into microservices. And these microservices needed to communicate, and they communicate towards what's called today a service mesh. All of this happens behind the scenes. None of us really have to deal with this too much. Istio is the main provider right now of a service mesh, and I think the ideal use case is that whoever has never heard of a service mesh before, you may also not have to hear about interoperability in 10 years with a blockchain solution. And ultimately, this provides a much better UX experience. Everyone that uses a checkout screen, it's usually the same cookie cutter screen because it's just copied and pasted for the most part for every company. So how do we bring that into Web 3? And that's something that Polymer is really focused on. We're really focused on bringing the network layer, which is the way that we're coining, which would be the service mesh for Web 3. So no matter how deep in depth our ecosystem gets within Ethereum, that we are able to use IBC as our standard to be able to connect these chains and be able to keep up with what applications need the most, and if they need layer 3s, that we are able to do that. This is really a fundamental shift towards a more scalable future because we are trying to holistically look at the market rather than chain to chain, just trying to solve immediate problems. Suffice to say, from a product standpoint, we are prioritizing the bottom half. So we're prioritizing the L2 to the L2 communication, and then next will be the L2 to L1, and then we'll work towards L3. So lastly, just to tie it all together, we really want to make sure that we are taking away some of these laborious constraints that applications have today. And how are we doing that? Via IBC. With IBC, the idea of this private network can exist. These chains can communicate via private channels and connections and have clients that they dictate is valuable for their use case. And lastly, Polymer takes that, builds on top of it within the Ethereum ecosystem. And we are then able to give that experience where right now, layer 2, these applications are independently getting deployed. Here it's one deployment on the optimal execution layer and really focusing on the ability to have L2 swaps. So even though these tokens today are non-fungible, there could be a world where they give much more of a fungible experience because they're all getting on a single state store on Ethereum and being able to be swapped across L2. And then ultimately, that single settlement, which means a single state that the application has to manage, that Polymer is able to manage, and bring the network layer into an application mindset to work with the chains. And here is just a cool image of the network layer sort of, again, being able to connect to Ethereum and connect in between the L2s and the L3s. And that is it. Thank you very much.